CCAM. Thank you that we're recording, yep. And Ignacio, the director of CCAM, is just going to say a few words to introduce CCAM. So take it away, Ignacio.
Yeah, Matthew, thank you very much. Hello, welcome everybody here to the afternoon in Central European time. Yes, as Matthew said, I am the current CCAM director, and I like always to welcome the events that we organize in campus as part of our flagship events. This is not part of what we call our workshops and events that go through a standardized procedure for selection from an independent scientific panel. But this is an event that came out in discussions with the organizers of this event. And it's strategically important for us in CCAM to understand how data, machine learning, AI operates, how it interfaces with, Matthew was mentioning experiments. I think historically, CCAM started, and is one of its characteristics in the development of algorithms, in modeling in particle-based methods, starting from atomistic and molecular simulations. But it's clear that we are now moving very quickly in a direction where the exploitation of data offers new possibilities to use simulations, to interface with experiments, but also I think that looking a little bit ahead, this is leading us into novel ways in which we will be integrating what we can do with machines, with computers. And in that sense, when we started discussing with the organizers of Madishes, it became clear that this was a very timely initiative because of the relevance of and the challenges associated to interoperability. So it was really a pleasure to work together to make this possible and to help you host this event. And indeed, I hope from CCAM, we hope this is fruitful and that it can serve to identify new initiatives that we can then also work together. In that sense, keep in mind that in April, we will issue the call for our standard activities that we fund for workshops and so on. And it could be a follow-up of this event if you consider that that's something that is worth building out to also submit a proposal and then organize an event next year, for example. I think this is an area where I see it from proposals we received that is growing in interest. And indeed, I think that's really timely and appropriate to organize it. At some point, we really were considering this possibility of having a hybrid event. Unfortunately, the situation with COVID is not as good, is not evolving as fast as we would like, so it has to be online. I think it was a good decision not to postpone the event. It's obviously not ideal to organize it without the possibility, especially in an event of this type where brainstorming and informal discussions are core, and still face-to-face meetings cannot be replaced by this online. But I hope that despite all that, we have worked together to provide a framework to facilitate as much as possible the interactivity. So I hope in that respect, it is really a truly vivid, insightful event where you can discuss openly and identify the challenges and what are the activities or the projects that you think are really worth pursuing. And as I said, if you decide to continue, let's hope that a next meeting of this kind can take place presentially, that we can welcome you in our premises. And then you can also further exploit the possibility of having informal discussions all along the event. So I will stop it here. I wish you all the best. I hope you really encourage the organizers for a truly interactive event, and then that it helps you and also us as a community to understand how to move forward in terms of machine data and interoperability. So Matthew.
Thank you very much, Ignacio. Yeah, it would be good to get back to CCAM hopefully in the new year or in this year. And we do sort of appreciate the support you've given us so far. Okay, so let's kick it off. I mean, I've been given the sort of responsibility to introduce the workshop and some of the topics we're going to discuss. So first, I'll just briefly introduce myself. My name is Matthew Evans. I'm still somewhere between a PhD and a postdoc, currently based at UC Louvain in Belgium. And I've sort of worked on the Optimade specification and other related data management projects, which have sort of taken me down this rabbit hole that brings me here today. And I just want to introduce as well the other organizers of the workshop. So with us here, we have Carlo Pignadoli from EMPA, Kevin Jablonka from EPFL, who helped with a lot of these slides, Stefan Kuhn from De Montfort University in the UK, Sebastian Huber from NCCR Catalysis in Switzerland, and hopefully joining us later on, Shyam Doranath, who many of you may know from his work on Materials Project and many other resources. And also from CCAM, we have Ord, who's going to be sort of facilitating this workshop. So please, well, thank you, Ord, for your help so far. And just straight from the outset, if you have any questions or feedback, first you can put them in the chat during this talk, and one of the other organizers will get to you. We also have this general email, and you can @manager if you're already on the Discord server. And if there are any sort of code of conduct issues or anything that needs to be handled independently, kindly CCAM will handle that through the director at CCAM address. Okay, so to kick us off, just some broad motivations of what we want to do when we talk about data management in science generally, but I guess more specifically in our field. The first thing would be to improve our scholarship. So an example here, I think we've probably all been down a rabbit hole of citations where we've struggled to reproduce a paper, or we've ended up hitting a paywall at some point when you follow descriptions of different protocols and so on to replicate experiments. And this is something that can be solved by improving data management tooling and much more sort of careful use of data in our field. And this sort of naturally then leads to the second point of enhancing research efficiency and I've called it equity here. So this is a sort of gratuitous nature cover. I mean, it's actually from our keynote speaker, Josh Scria, a paper he published a few years ago about how you can add your sort of so-called failed experiments into your machine learning models to improve their performance. But this sort of touches on how we can improve our data capture and publishing such that people learn from your failures. If you're working within a particular group, people often will have niche expertise where they tried an experiment and there was something sort of quirky about it, for example. How can we sort of capture that long tail data and make it more accessible and equitably available? And then finally, I mean, as someone with a computational physics background, this is my idea of what chemistry is. It's well, I don't think of you as robots, but this part, at least, the mixing stuff together in jars is chemistry. And hopefully in the future we'll be hearing about automated labs and using robotics and so on, and how that can interface with our field. And really, this is sort of new scientific paradigms of not just machine actionable data as in our title, but machine actionable science, where we can really gain new insights that perhaps human experimenters wouldn't have been able to find, either because it's too laborious or you just need a completely different scale of approach. And we focused, or we tried to focus the workshop down on sort of one technique. I think this was mostly to sort of break the symmetry on any discussions we have. So if we need an example case, we can try and frame it in this in the realm of X-ray absorption spectroscopy. And we're actually really lucky to have some sort of real domain experts in this area who are going to be giving talks this week around their own efforts for data management. And it's a good technique to choose because it's something that's very sensitive to how you process your sample and your material that you take your sample from, and also your data and metadata. So instrument parameters and your baseline corrections or whatever. All of this stuff needs to be captured to make it sort of reproducible. It's a technique that's widely applied across lots of different sort of scales. So from sort of research labs to commercial labs, up to sort of synchrotrons and facilities. And it's a technique that can be simulated. So, we have then lots of interesting links to computational data and to machine learning and how we can sort of contextualize those. And also, of course, we're not saying that people haven't been doing these things already, right? There's many existing formats for good formats for data interchange, especially around X-ray absorption. And these are all sort of a varying compatibility with each other. And I think, we really want to build upon these existing initiatives rather than sort of tear it all down. But that said, I mean, so I would say the three main challenges that we want to address in this workshop, in this field, is how you can sort of contextualize the spectral data within, say, a broader set of experiments, or just linking it to a particular sample, for example. How you can publish and share this data with reusability in mind. So publishing in sort of self-describing formats that have the context that's required. and also alongside any sort of bespoke software or tooling that was used to analyze it, and how you can publish this data in a discoverable fashion. So, we're finding lots of data nowadays ends up on these sort of general purpose repositories. It's just a zip file with a README, and it's quite difficult then to actually do anything with that data. So even though it's open, which is great, and that battle's been won in some sense, the next step is then how we can sort of enable discoverability and unification across different data sets. And to do this, well, we've invited a lot of different initiatives. This is just the subset of initiatives that could actually make it to this workshop, which is, it's been really encouraging to see such a good uptake. I'm not going to sort of go through all of them, obviously, but a lot of these, the sort of common thread is that these are quite large scale initiatives. So in particular, the NFDIs have all been funded fairly recently, but they have sort of many members, many different organizations collaborating within those organizations. And I think we want to sort of capture the scale of some of these initiatives and get them talking to each other and having their sort of work filter down to the groups that don't quite have the resources to tackle this stuff on their own, but would like to. So the topic of the workshop is interoperability. We should probably at least vaguely define it. So a very technical definition or a very sort of vague definition would be that two entities are interoperable if they can be sort of interfaced directly with each other without a sort of mediator. And there's plenty of examples, but one you're probably very familiar with would be your web browser accessing a new website. You think about the sort of technical standards in place to actually make that possible. It kind of the mind boggles. So you need TCP/IP, HTTP. You need electrons moving around the world, or photons, I guess, moving around the world in most cases, to actually transport the data. And yet, you can render our website, hopefully, depending on your browser version, in such a way that it means something to a human looking at the screen at the other end. And then some more simple examples would just be, that you can plug your laptop charger or something into a wall and it doesn't blow up. It's, there is a standard that's been in place there to make sure to maintain voltages and that the socket actually fits. And then even simpler would just be, if you have a nut and you need to buy a bolt for it, you can just sort of provide the size and some other details, and straight away you have something that is going to work. So bringing this around to chemistry slightly, we could say that interoperability here will enable scalability. So here's sort of four, well, I guess lab notebook solutions that are actually represented here. You can imagine sort of writing adapter code that sort of goes between each of them, and maybe they all link to sort of persistent definitions in Wikidata, as we'll come on to. And you end up with this sort of combinatorial growth of these pairwise adapters, which in some sense it isn't scalable at all, right? So this kind of interoperability can actually impede scalability. And I was kind of loath to include an XKCD, given that my physics undergrad was absolutely saturated in XKCDs, sort of being shown by lecturers to make a point. But this one is actually quite relevant. So the idea that when you have 14 competing standards and you need to somehow come up with one universal standard that covers everyone's use cases, ultimately you end up with 15 competing standards. So that's something we obviously don't want to address really in this workshop. We would like to talk about ways we can make the multiple existing standards interoperate through sort of careful design without necessarily inventing any new ones. And interoperability itself, in the sort of more technical sense now, can be categorized into three sort of levels. So syntactic, structural, and semantic interoperability. And syntactic is kind of, at least from this particular definition, is kind of solved, right? It's just the way that you would decode the encoding of a file. So in reality, it's just zeros and ones or electrons in your computer. We know how to decode that into something that your computer can make sense of. And then structural interoperability, being able to decode the sort of organization or layout of a file, say. So that you can, these 8 bytes corresponds to an integer, or 8 bits corresponds to an integer. Then adding sort of more advanced data structures like lists and dictionaries on top of that. So when your computer opens a JSON file, it automatically highlights things. That's because it knows about the layout of a JSON file and it can understand that. Then the real challenge comes, at least for sort of scientific data, is this semantic interoperability, where you then need to decode the meaning of the data as it was taken. And this kind of sort of cartoon sketch graph, whatever you want to call it, at the bottom here, shows how, you know, the resources involved in, you know, the time and cost resources involved in making data semantically interoperable. Well, I mean, this graph doesn't show much, but it certainly increases as you add more layers of semantics on top. So, you know, in chemistry, we still tend to publish things in free text often. Where you end up with this sort of folksonomy that if you have the domain knowledge, then you can understand the paper. But certainly there have been many you know, attempts of making things control vocabularies to make this much more precise, and then thesauruses that map between them. But really, to get this sort of semantic interoperability, you need sort of hierarchies of these terms, so a taxonomy, all the way up to sort of full conceptual models and ontologies, which are a bit scary, but I think this audience is already quite familiar with them, or most of this audience is quite familiar with them. And I should say at this point, I mean, we do have quite a broad audience. So if you look on our website, we've actually put a glossary. So lots of acronyms get used around this field and lots of scary words and philosophies. And if you're interested, there's lots of resources there you can probably pick up and learn something from. And then finally on this point, so you're probably already aware that we're going to have some breakout discussions. So I'm going to start sort of highlighting topics that correspond to some of the things I'm saying in these slides. So this kind of stuff we're going to be talking about in the what to standardize room, in the reusability room, and in the fuzziness room later on. So just sort of make a note of that mentally. And so fundamentally what we have here is this sort of collective action problem, right, in science, that to make your data interoperable, it can be at quite a great personal cost. And it's not always clear that there's actually any benefit to you as an individual scientist. So this picture here just shows the sort of data commons framework, showing some of the sort of levels of stakeholders involved. So to get all the way up to this sort of full semantic interoperability, you know, where a human can sort of gain knowledge, or, you know, in our case, I guess a machine can somehow have a conception of that knowledge. You need all these other layers. So you need the sort of the institutions in place for managing accessibility. You need the sort of practices, so things like funding and incentivization of this work. And this is obviously all built on top of the actual technical work of having formats and labels and for the metadata and taxonomies and the actual data itself. And again, on the left here, so the breakout topics that kind of align with these areas, so that maybe you find more interesting. So we have a breakout on the sort of very human topic of how we maintain this kind of work and how we, you know, the kind of governance structures, I guess, around this kind of work. And also the incentives and benefits of why we actually might want to do this and what things we can do that would incentivize future work. Then somewhere in the middle, we have this idea of agility of standardization. So how we can make sure our standards can sort of evolve as they need to, how they can be flexible and extensible. And then more on the technical side, as I say, is the three breakouts I just mentioned about what we actually standardize, reusability and fuzziness. So bringing this around to scientific data, of course, there was going to be a slide on FAIR data. I'm sure this is sort of familiar to many of you. The FAIR guiding principles published in 2016, building on sort of work of the decades before that. You know, it's become a sort of touchstone, I guess, for a lot of the work in this area. Dare I say a buzzword for a lot of this work in this area, where people want to be seen to be fair. I think because it's such a good acronym. So the idea is that scientific data should be findable, accessible, interoperable, and reusable. And of course, we're going to focus on interoperable in this workshop. And I was rereading the paper and I just sort of pulled out a couple of key quotes I wanted to mention. So the first is how the paper sort of opens, which is that good data management is not a goal in itself, but it is rather the key conduit leading to knowledge discovery and innovation, and then to subsequent data integration and reuse after the publication process. So this is, you know, quite actually a strict set of principles that do take us a very long way. And you know, I'm not sure in the sort of 5-6 years since this was published that we've really done all the work there yet. Well, I know we haven't. The second quote is about machine actionable and the sort of start of our workshop title. So after defining machine actionable in the paper, they then go on to make this important distinction between data that's machine actionable as a result of specific investment in software supporting that data type, which I think, you know, sort of summarizes a lot of work we already have in our field and things like on like JCamp and SIF and other sort of spectral data interchange formats. And then this is in contrast to the data that is machine actionable through the utilization of general purpose open technologies. And, you know, the point here is that you can then link across domains, or you can link across data models or across different collaborations that have all agreed on the same data format. So although this first set of data types and things are really important, we still have a lot of work to do to link these with sort of more general purpose open technologies. And I guess if you're already sort of well versed in this area, you realize we're sort of talking about linked open data without saying the exact words. So this is the sort of idea of 5-star data introduced by Tim Berners-Lee, and probably people before him as well. He's where I've pulled it from, where you have this kind of hierarchy of different ways of publishing data on the web, not scientific data necessarily, just sort of data. And of course, this is what sort of forms at the top here, the semantic web, or Web 3, if you still believe that's what Web 3 is. And I guess, in chemistry, we're still very much lingering around the bottom, or chemistry and material science, lingering around the bottom of the rung here. So, archive with an open license, I mean, journals these days at least are starting to come around to open access, although of course that's another big discussion that I'm sure many of us are interested in separately to this workshop. But things like spectral data are still commonly found in PDFs as just images that you would have to measure with a ruler or copy yourself somehow to actually get the data inside them. The one step up from that would be sort of adding structure to that data. I mean, they choose the example here of Excel files, which I think many of us know have many issues that I do not have time to go into. But some of them have sort of terrible real-world consequences, I guess, particularly the sort of track and trace issues using Excel in the UK, in my country. I think a lot of the time now we are seeing at least people publishing in open formats. So CSV would be an example of a sort of domain agnostic formats, but certainly people publish their spectral data in good open formats. And this is then the kind of the archives that end up with, README on a general purpose archive, say, or general purpose repository, I should say, which is great. But if everyone comes up with their own format for, the fields they're actually trying to serve, then the machine actionable nature of that data, is limited. So you really only get the sort of semantic interoperability in these top 2 steps, where you've started to use, maybe a more general purpose sort of framework like RDF, which I'm sure we'll hear about from some of the other talks this week, where you start using persistent labels for your concepts, I guess, that you're presenting. And then eventually to really enable the sort of, or unlock the value in that data, you start linking out to other sort of pieces of RDF and start building sort of maps, knowledge graphs, and so on, or sort of secondary databases that can then be used to, think of creating machine learning data sets, for example, from sort of trawling these graphs. So that's sort of what we're here to talk about, I guess. So this is just a quick summary slide of some of the technologies already in use. I probably don't have time to go into all of this. In fact, I'm not sure if the notifications I can hear is someone telling me I'm already running out of time, but I think I'm okay for now. So just to sort of categorize these technologies into this sort of very continuous spectrum from sort of file formats to data models, to then resource layouts, where maybe you've got sort of an API that's serving particular sort of atoms of data that are sort of semantically useful in your field, up to how you describe those resources precisely with sort of resource description frameworks. So you can see down at the file format end, we've got some good examples like HDF5 and even CSV and JSON when used correctly, and some sort of worse examples of Excel and proprietary formats. And commonly, in machine learning in particular, people sort of pickling their models in Python and expecting other people to somehow or depickle them and have the correct environment set up to be able to do that. So really, you need some sort of data model on top of these file formats. And in our field, that's where Nexus and SIF and JCamp have come in. And then you can think of an ELN almost as a data model as well. And in machine learning, there's this new formats like the ONNX for sharing neural networks across lots of different machine learning packages. Then moving more towards resource layouts, things like AnyML, XDI. We're going to hear about IUPAC FairSpec later on today and Optimade throughout the week that sort of describe more how you would lay out data such that you can link files together in a particular way and have a sort of implicit semantics around sample-based or structure-based data. And then all the way up to ontologies. So, I mean, IUPAC and RSC themselves develop some ontologies. And this is where you start talking about the more sort of semantic web technologies like RDF and Sparkle. and CML. So the next speaker, the second speaker today will be Peter Murray Rust, one of the developers of CML, which allows you to sort of describe very precisely chemical objects in a semantic way. And just to sort of, again, bring this together with different stages of the sort of research workflow. So I've taken these steps from the Nist research data framework that some of you may be familiar with, published a few years ago. So they sort of sketch out this workflow for, I guess, generally sort of science, but data management. So how you would envision and plan your experiments, how you then generate and acquire your data, how you process it, share it, and then eventually preserve it. And I would say we're focusing on the last four in this workshop mostly. And the tools we're going to be talking about are going to be sort of lab notebooks, electronic or otherwise. You're going to probably hear about people doing OCR on non-digital notebooks, which is interesting. How you actually get your data from instruments, so how you have like acquisition orchestrators and lab information management systems and various other sort of complicated things. But then just sort of general libraries and the standalone apps that are maybe more traditional scientific software use cases. And then I think something that's becoming much more common is people writing bespoke sort of scripts and notebooks and other code objects that are, need to be shared alongside the data to actually properly contextualize it and make it reusable. So sort of getting ahead of that and writing good recommendations for how to do this, I think for our field is going to be very useful. And then of course, how you actually sort of archive this, or how you store this data as you're creating it in different repositories, and whether it should be a static data set or something living that can actually be versioned itself and sort of appended to, are all sort of useful topics. And I know I am running out of time now, so I'll just very briefly mention the Cathedral and the Bazaar as the sort of an example from open source software, at least, and the Linux kernel from Eric Raymond of two different sort of governance structures, I guess, for developing sort of technical standards and software, and how that could apply to our field. So that you have this idea of a cathedral where a sort of blessed few experts are the ones that develop the standards, and then they stand outside the front of the cathedral and announce to the world that they have created these standards that everyone should use. That's sort of one approach that's can be certainly very powerful. But we're seeing more, I think, science move towards the Bazaar model. That's Bazaar, not Bizarre, model more as time goes on, where people are sort of naturally going to publish their own bespoke self-described formats, or hopefully self-described formats and definitions and things that actually solve their problems. So sort of bringing these two approaches together, I think, is important to actually sort of make progress in this area. And speaking of standards, I have actually broken one standard already, which is that of the Catholic Church. So if you were paying attention, this actually isn't a cathedral. It is a minor basilica, which can only take the rank of cathedral if it is in a diocese that doesn't already have a cathedral. And you'll recognize that this is Florence, which has its own cathedral. So we should be careful to adhere to standards where they do exist and make use of them. But I would posit that our field maybe looks a bit more like this at the moment, where there's sort of people milling around wanting to do things, wanting to sell their wares, but they don't have their own stand. They don't know how to sort of describe their data that they have captured in their own formats. Okay, so that was most of the sort of rambling about our motivation. I'm seeing it's now 2:30 already. So I'll sort of rush through this part, I think, about sort of who you are and who we've actually brought to this workshop. So I made this slide yesterday when we had 118 registrations. Some of you were very late and registered today and this morning through sort of more manual means. So I think we're nearly up to 140 now, which is fantastic. And there's a big spread of people from experimental, computational, and informatics sort of researchers and engineers. So the 50 or so people that filled out the pre-workshop survey, you can see we have a very good mix. And we didn't actually sort of ask people their domains, but I think we can tell from the responses that we have people all the way from sort of molecules up to metallurgy and processing. We have a few life sciences and bioinformatics people who are going to hopefully give us some great insights that can work across domains. And you can see from this survey that there's lots of different technologies that are already in use from these attendees. So hopefully there's a lot you can learn from people here. There's certainly some groups missing, so we didn't get a huge uptake from the industrial people we tried to invite, nor societies. I say we have some great talks from X-ray data specialists, but I think the majority of the audience aren't necessarily sort of primarily X-ray people, and we sort of didn't really get any instrument manufacturers to turn up. And one important sort of section is research PIs, so those starting new labs where you can sort of really get in early and come up with your own data management procedures, and it'd be great to sort of support those people and try and encourage good practices there. So please do sort of spread this amongst your networks, even if they can't come to this workshop in particular. We're hoping this will be something that sort of carries on. Okay, so for the sake of time, I'm going to sort of skip over these bits. But again, from the workshop survey, we've tried to tailor the stuff we're going to discuss to the user stories you came up with. So lots of sort of frustrations that have already been shared in some of the stuff I've mentioned about being unable to sort of reproduce things in papers or sharing things just as a zip file in general repositories, and how that's sort of not necessarily useful. And we'd like to sort of harness some of these sort of gripes, I guess, and motivate some hacking. I mean, I don't know if that's the right word for it really, but we've got a hacking room on Gather, which you should have a link to already. And this morning we just sort of sketched out a couple of potential projects for people to work on this week. So if you sort of prefer to do that over joining breakout discussions, so please, feel free to use the normal GitHub processes if you're familiar with them, or just reach out to us and just join the hacking room and talk to people. So we have a quote here from Peter. I'm not sure if he's aware we're including it, but it was on GitHub, that we need something messy, and if it works, that's the important thing. It doesn't we can just redesign it once it's there. And things that are perfect that no one uses, haven't really done anything, haven't achieved anything. So we are really looking for just sort of brainstorming and sketching out some ideas in this workshop this week. Again, I've sort of gone over some of this stuff, but Kevin was able to do some sort of word analysis on the responses you gave. You can see lack is the biggest word here, but this idea of lack of incentives and lack of standards, and people also focused on sort of lack of discoverability as well as some of the main barriers they find. So onto the concrete aims of this workshop. So these are on our website when you signed up, so perhaps you're already aware of them, but we are aiming to prepare a perspective paper that will be targeted at providing some recommendations to sort of new projects in our field based on some of the considerations you guys have already come up with in your own projects. And this is something we'd like to write with the community if we can. So if you're already on the Discord, you'll see we have a channel for that, and hopefully this will continue after these 3 days. We'd like to identify some particular challenges that we think can be overcome via new collaborative software libraries and infrastructure. So things that perhaps reach between the divides of existing projects. I think there's several people here would be interested in volunteering to sort of work on some open source code there. And then finally, we want to motivate follow-up meetings, as Ignacio said. So new hackathons, new cross-initiative collaborations, and ideally a new sort of community of practice would be fantastic outcome of this workshop. So today's, the sort of general program, again, you've probably already seen, we'll have 3 sessions on most days. Well, sorry, 3 sessions tomorrow and then 2 sessions on the final day, so not most days. And these will be in the morning, afternoon, and evening, roughly according to the EU time zones at least. They're going to start with some short talks, and we'll end with an hour and a half of discussion, in most cases, on the breakout topics that we've taken on GitHub. But the idea is that these topics, sort of meander and evolve as the week goes on. The social sessions and hacking and informal discussions will be on Gather and Discord throughout. There's nothing there's one thing sort of timetabled, but other than that, please just join and sort of mingle, I guess. And the latest program is always going to be on our website, so you can check that out there. I've already mentioned quite a lot of the breakout room topics, so I just want to say that we do have sort of fairly wide interest across all of them, so I'm hoping for some good discussions there. And if you can, take the time to read some of the introductory material we have for them, that might help you sort of best choose which breakout you think you should join. And I guess there's sort of 2 streams of how you can participate in this workshop, depending on your background, your expertise. So if you're really sort of a linked open data expert, there will be discussions where that sort of stuff is good to talk about, much more technical ones. But if you're more on the sort of sciencey side and the chemistry side, there'll be lots of discussions where you can talk about the problems you face in your own research, and maybe get feedback from other attendees. So just to bring it back to the code of conduct, we are following the citizen code of conduct for this workshop and generally this community. So this was originally developed for the Django software project. So by registering, I mean, depending on when you registered, I think the wording was changed, but you are sort of implicitly or explicitly agreeing to these guidelines. So do take a look. Hopefully there'll be no issues, of course. But if you do have anything you need to report, director@ccam.org is the place to do it. This will be handled independently of the organization team and of course confidentially. So final couple of slides just to wrap up on the logistics. I'm not expecting you to sort of type this link in, but you should have received a link to the Discord. And we apologize that the one we sent out a few days ago has already expired. This should now be a permanent link. And the idea of the Discord is just to sort of gather people together. We can make announcements on there and we can sort of get some more informal discussions going asynchronously. There's then the gather room, as I said, for sort of synchronous discussion. We just want to sort of chat and meet people. The only piece of sort of structured fun we have, structured socialization, is the speed networking session after this, after the next set of talks. So that'll be at 5 p.m. UTC. So that's sort of a good time for EU, I guess, time zones to sort of kick back. And maybe for American time zones, it's slightly trickier to justify during work hours. But depending on whatever you need to say, this could be informal discussion or it could just be sort of relaxing, I guess. And then the details of the talks should be sort of obvious as we give them, so I won't go into that now, except that the Zoom links will be sent out after each talk. And that means you can sort of catch up again asynchronously. And I should have said as well that this talk itself will be sort of rebroadcasted on Zoom at 6 UTC in case, well, I should have said this for the people who have probably woken up early to watch it. I'm sorry, you could have probably gone back to bed, but this will be available again at 6 UTC. So to finish off, just again like to acknowledge CCAM and also the Marvel NCCR in Switzerland for sort of helping us organize all this. If you have any questions or feedback, you can sort of ping us on Discord. And I think I'm getting lots of notifications now of people joining the Discord, which is great. I was worried that that was someone telling me urgently I've done something wrong. As I say, any code of conduct issues, please contact CCAM. So the next thing we're looking forward to is our keynote talk. We didn't quite have time to squeeze in what the title is going to be, so it will remain mysterious now. But I'd like to welcome Professor Josh Skria,